Welcome to The Explainer. Let's jump right in. Today we're looking at a brilliant piece of source material that completely strips away the heavy jargon usually surrounding artificial intelligence. You know, even if you work in tech every single day, you've got to appreciate how this guide breaks down complex AI architectures using a surprisingly simple, elegant framework.
The source material actually makes this incredible promise. I'm going to teach it to you guys like a kindergarten teacher. It takes these massive, super intimidating technical concepts and just treats them like simple building blocks. And by using this unique mental model, understanding how machines think, well, it isn't magic at all. It actually becomes incredibly intuitive.
So here is our curriculum for today's AI kindergarten class. First, teaching machines like kindergartners. Second, supervised versus unsupervised learning. Third, brain-inspired neural networks. Fourth, deep learning gets complicated. And finally, generative AI and creating the future.
Section 1. Teaching machines like kindergartners. Think about how we used to deal with computers, right? We'd have to program them manually, writing lines and lines of rigid code in languages like Python or Java. But machine learning completely flips the script. Instead of traditional programming, machine learning is literally just teaching machines by showing them lots of examples. You give the machine tons of data, pictures, text, numbers, so it can eventually recognize patterns and replicate them. Honestly, it's exactly how you teach a toddler with flashcards.
Section 2. Supervised versus unsupervised learning. How machines learn.
Now, there are two primary ways to run these learning exercises, and we really need to contrast them to understand exactly how machines categorize the world. The difference is actually pretty stark. With supervised learning, you learn from specific, labeled examples, where the clear answers are just handed to you. Unsupervised learning, on the other hand, is entirely about finding natural patterns and groupings in random data completely on your own, with zero labels.
Think of supervised learning like a fruit cart analogy. Just like teaching a kid, you point to a picture and say, hey, this is an apple. Then the next one, this is an orange. You're providing the exact label. The source points out this is exactly how your phone's Face ID works. The system is explicitly trained on your unique facial structure. Because of that supervised data, it knows exactly what you look like, rather than wildly guessing and locking you out because it thinks you suddenly look like Thanos.
Conversely, unsupervised learning is like throwing dozens of completely different unlabeled dogs and cats into a room. You don't tell the machine their names, you just let it group them by physical similarities entirely on its own. It separates the cats from the dogs just by spotting those natural patterns. And you know what's interesting? This is the exact same mechanism YouTube uses. It groups and recommends similar videos to you based on patterns in your viewing history completely automatically.
Section 3. Brain-inspired neural networks, brain-inspired learning.
So the crucial point here is that a neural network is a subset of machine learning that directly mimics how human babies learn. We're moving away from simple database sorting here and heavily simulating actual biology. It uses these deeply connected simulated neurons to process a whole jumble of information, literally inspired by the physical wiring inside our own heads.
And it operates in a beautifully simple flow. Step 1, input information. You feed the machine data. Step 2, that information travels through various connection points, firing exactly like the physical wiring in our brains. And step 3, the network evaluates it. It actually thinks about the data and spits out a logical conclusion.
Section 4. Deep learning gets complicated.
Now, once we understand that basic brain wiring, we can start adding more lights, more wires, and a whole lot more complexity. Deep learning is, at its core, really just a much more complicated neural network. If you add more connecting lines between the individual neurons, the network becomes highly dense, meaning tons of communication wires. But if you add more layers of individual dots, well, that makes the network deep.
The source drops some heavy jargon here, but we can easily group these network architectures into simple buckets. DNNs, or dense neural networks, primarily handle text and speech. CNNs, or convolutional neural networks, handle images and video, like that face unlock feature we were just talking about. And RNNs, recurrent neural networks, they handle recurring data patterns, like spotting two similar-looking dogs that pop up again and again in a set of images. Section 5. Generative AI, creating the future.
All right, we have finally arrived at graduation day for our AI kindergarten class. And we really need to ask this specific question because, you hear this term absolutely everywhere nowadays. What exactly is generative AI? Based on all the building blocks we've covered so far, what is it actually doing?
Well, unlike the old AI that just categorizes things, predicting your face to unlock a screen or suggesting a YouTube video, generative AI represents a massive leap forward. Systems like ChatGPT take absolutely everything they learned in their basic training and use it to create brand new content from scratch. We're talking generating original text, composing new music, or painting totally unique images. It's not just sorting anymore, it's creating.
Which brings us to the end of today's explainer. As our source notes at the conclusion of their 30-day challenge, simply watching and listening isn't quite enough. You have to revisit these concepts, truly grasp the foundation, and eventually put these exact building blocks to work yourself. You've officially graduated kindergarten. So, the ultimate question is, what will you train your AI to do?